I don't know whether you heard about this, but there are a lot of locations in the solar system where life may exist, and Europa is perhaps one of the more promising ones. One of Jupiter's moons, Europa, has oceans of liquid water buried beneath its icy exterior. But be careful. Contrary to what you may believe, this surface is much thicker, perhaps 20 kilometers thick. Nevertheless, one of the potential problems with this type of surface is that it might not have enough oxygen to support life. In fact, oxygen often tends to build up on the surface, and it is unknown how it may enter the ocean below the heavy layer. It's also possible that this ocean of liquid water has the capacity to support life, but that would be a waste of potential if there is no oxygen present. Although it is possible for some types of life to survive without oxygen, this is highly improbable, or, to put it another way, the presence of oxygen would increase our chances of discovering extraterrestrial life. Thus, the query is there oxygen on Europa? Further missions will be required to fully comprehend it, but recent studies have raised the possibility that we may have discovered a plausible pathway for oxygen to enter the liquid ocean. Watch to see how. Everything begins on the surface, on what scientists refer to as chaotic terrain because, well, it's a mess. The cold, brilliant surface of Europa has a topography unmatched on Earth. To begin with, there aren't many imposing mountains or vast plains, so it's generally pretty smooth. The surface is crisscrossed with countless ridges and grooves, dividing the terrain. Several of these structures are accompanied by lengthy, curving streaks of dark, reddish color, some of which extend across the surface in vast arcs of more than 600 miles, 1,000 kilometers. At other places, icy block jumbles, pits, and domes give off the impression that warm ice may be emerging from below. Europa, Jupiter's frozen moon, has a surface made of thick layers of ice. Its freezing white plains are scarred by glacial ridges and fissures that cut roots across an icy shell that hides a vast ocean of liquid water. In locations known as chaotic terrains, which are extremely disrupted and where slabs of ice appear to have broken off, drifted, and then refrozen to the surface, the moon's shattered topography may be seen up close. Researchers searching for an explanation of how these features developed have discovered one after looking at photographs of Europa taken by NASA's Galileo probe. Large lakes form inside the moon's crust as plumes of warm ocean water rise to the subsurface. Some of these lakes are bigger than all of North America's Great Lakes put together. The floating geometric shards rotate, raft, and settle into a variety of erratic patterns as the ice directly above these lakes breaks down over time. If such events take place, including the transfer of ice from the surface to the interior and back again, certain oxygen passageways may occasionally open, giving us hope for life on Europa. Europa has extremely low temperatures, however there are some areas where the salt concentration is sufficient. Some of this water might pass through the ice layers, catching oxygen along the way, bonding with it, and carrying it through the ice layers with it. In an effort to simulate these conditions accurately and determine what is likely to be occurring there, physicists tried to duplicate these conditions. The concept has actually been around for a very long time, but scientists have never attempted to come up with precise scientific explanations previously. We now appear to have a model of what is happening in Europe for the first time. The University of Texas researchers discovered that ice porosity varies with the saltiness of the water, which means that the more salty the water, the more porous the ice is, and the greater the likelihood that oxygen will reach the ocean. They refer to it as a porosity wave, but what actually occurs is that some holes are made at the saltwater passage. Once the water has passed, these holes then close, allowing the oxygen held in the salty water to enter the ocean. We don't really know if this actually occurs, but if it does, 86% of the oxygen created on the surface could end up in the ocean below, creating an ocean that is sufficiently comparable to the oceans on Earth. How can we determine if everything here is true? We must launch missions that can provide us with thermal and perhaps chemical maps of the moon's surface. Europa Clipper is the name of one of them. It is expected to launch in 2024 on a Falcon Heavy, and it will fly over Europa at least 35 times. As a result, it will collect data and relay it to Earth. It's a lot, 35 flybys. With such a vast amount of data, we will be able to create high-resolution maps. But if Europa Clipper launches in 2024, we may anticipate it to arrive by the end of the 1920s. As a result, in the 1930s, we will have 2 missions orbiting the icy moon of Jupiter, since JUICE, another European mission, would also be passing by Europa on its way to explore Ganymede. Hence, we can anticipate that JUICE and Clipper will bring about a revolution in the study of iced moons. The 9 sophisticated instruments on board the Europa Clipper mission are designed to investigate the geology, chemistry, and habitability of Europa's innards and ocean. A 150-kilogram titanium and aluminum barrier will shield the electrical components from the strong radiation. The orbiter's 9 science instruments, which were disclosed in May 2015, are thought to weigh 82 kilograms in total. To help identify geologically active locations and regions, such as potential vents erupting water plumes into space, the Europa Thermal Emission Imaging System, for instance, will provide high spatial resolution and multispectral imagery of the surface of Europa in the mid to far infrared bands. Instead, the Europa Imaging System is a wide and narrow-angle visible spectrum camera equipment that will scan the majority of Europa at a resolution of 50 m and produce photos of specific surface areas at a resolution of up to 0.5 m. Europa Clipper's payload and other equipment will be encased in a thick-walled vault because Europa is showered in radiation that has been trapped in Jupiter's magnetic field. The NASA Juno spacecraft devised and utilized this approach of arming up to go to Jupiter with a radiation vault for the first time with success. The titanium and aluminum vault walls will serve as a radiation shield against the majority of high-energy atomic particles, significantly delaying the deterioration of the spacecraft's electronics. Recap now. Even while it may take some time for us to determine whether there is life on Europa, finding oxygen would still be a huge discovery because it would increase our chances of finding extraterrestrial life. But what if we discover that one of these chaotic areas is capable of supplying the oceans with oxygen? Since scientists are well aware of this possibility, they are already considering their next step, which would be to land a lander on Europa. We could study and melt some ice that had been carried to the surface of the ocean during one of these chaotic occurrences if we launched a lander to Europa, and we could then look for signs of life there. We might even consider landing on Europa and using high-tech tools to break through the ice there in order to create a passageway for a small submarine that can travel to deeper waters. Although it is not impossible to do these things, it is unlikely that we will have the good fortune to witness them. It is more likely that our children or grandchildren will achieve these things. But landing a lander on the surface of Europa will be quite challenging because the moon's surface is so unlike to anything we have ever seen. Hence, even if we had unlimited resources, we would not be able to safely land on the Earth. Even if we succeeded, we would still need to take into account that Europa is quite close to Jupiter and is hence highly exposed to radiation from the planet's magnetic field. Of course, this will be difficult for our instruments, and they might react differently than usual. As Jupiter is so far from the Sun, we would also require batteries, but we wouldn't know how to recharge them. The usage of plutonium sources may be possible, although that has to be seen. For instance, if you wish to work as an aircraft engineer, you might like becoming closer to these urgent concerns. Before we conclude this movie, we would like to mention that the Galileo orbiter mission was another spacecraft that has already provided us with invaluable information about Europa. Before the mission's conclusion in 2003, the Galileo spacecraft and probe had completed 34 orbits of Jupiter and its natural satellites since their 1995 entry into the Jovian system. This color image, captured by Galileo, emphasizes the mysterious, fascinating surface of Jupiter's ice moon Europa. This color image of Europa provides the greatest quality view of the largest area of the moon's surface. This rendition was made by combining the photos to get a realistic color representation of the surface that simulates how Europa could seem to the human eye. The scene demonstrates how astonishingly diverse Europa's surface geology is. The surface is covered with long, straight ridges and fissures, broken up by areas of disordered topography where the surface ice crust has been broken up and refrozen into new patterns. Several geologic feature types and locations are linked to different surface color variations. For instance, sections that seem reddish and brownish contain higher quantities of non-ice components than areas that appear blue or white, which contain relatively pure water ice. The more equatorial latitudes, which appear more white, are considerably bluer than the polar regions, which are seen at the left and right of this image. The two places' different ice particle sizes are assumed to be the cause of the color discrepancy. Thanks, Galileo. Thank you everybody for watching. What do you think of this video, guys? Did you know that life could exist on Europa? Please let me know in the comments section below. Don't forget to subscribe, and I'll see you on the channel again soon.